I wanted to make this quick video so that you guys don't fall behind my other classes. Unfortunately, I'm not able to be here with you in class today, but I think that this video is going to help you guys to not fall behind. So where we left off, we had already finished all of this. We left off right here. Find an exponential function from its table of values. So at this point, you're going to have to go ahead and, well, what they're asking you to do is that they're asking you to find the equation for g of x, right? So g of x, and if we go back to the top, remember that our parent function is a times b to the x. So g of x is equal to a times b raised to the x power, okay? And they're asking you to find g of x, and they're asking you to find f of x, which is also a times b to the x power, okay? Now, what you're going to want to do, ladies and gentlemen, is you're always going to want to look for this first. Okay, so this is a table of values, and this one's for g of x, and this is for f of x. And you're going to want to look for the table of values where x is equal to 0. And the reason for that is because your a is always going to be the value at x is equal to 0. So right here it says when x is 0, my g of x is 4, then that must be my a. Right? We can prove it by plugging it in. A times b to the x power is equal to, I'm sorry, what I meant to say was a times b to the 0 power, right? Because we're plugging in 0 for x, is equal to 4. Okay? Now, as we discussed, b to the 0 power, or anything to the 0 power other than 0, has to be 1. So this is a times 1 is equal to 4, which just means that a is equal to 4. Okay, now to find our b, we just go ahead and use the value where x is equal to 1. Okay? So to find b, we go ahead and say, okay, well, if a is equal to 4, then I plug it in. 4 times b to the x has to give me y, right? Or g of x. So now I plug in 1. 4 times b to the first power is equal to, well, when x is 1, then my y, or my g of x, is 12. And then I go ahead and say, well, b to the first power is just b. So 4 times b is equal to 12, and when I divide by 4 on both sides, I get b is equal to 3. So when it's asking me to find my equation, g of x is equal to 4 times 3 to the x power. Okay? And then I had my other classes do this one on their own, so go ahead and try it out. Y'all can pause the video, try to do this one on your own. Give you a couple seconds. Okay, assuming you pause the video and you tried it out yourself, I'm going to give you the solution. For this one, we do the same thing, all right? We find out when a is equal to, when x is equal to 0, we get our a, right? So a is equal, a times b to the 0 power is equal to, in this case it's 8. So a times 1 is equal to 8, so a has to be equal to a. 8 has to be equal to a. And so when we plug it in, 8 times b to the first power is equal to, in this case it's 2. So 8 times b is equal to 2. When we divide by 8 on both sides, we get b is equal to 1/4. And so we're going to get 8 times 1/4 all raised to the x power is equal to my f of x. And there we go. Now, I know in some classes we already talked about e, but there's really only a couple things that I want you to know right now. I want you to know that, number one, this is a constant. All right? Constant, it's the opposite of a variable, which means that it doesn't change, right? The value of e doesn't change. It's approximately 2.718, okay? So whenever I ask you what e is, you can kind of think of it like pi, right? And this actually stands for Euler's number, I believe. And And it's kind of similar to pi in the sense that pi is a symbol that is also a constant, but that represents a value of around 3.14. And just like pi, this is irrational. It keeps going, right? So it doesn't end there. That's all I really want you guys to know about this for right now. Transformations. Moving on to transformations. Really, this is just review over what we've already done. If you guys remember what we worked on last time when we were dealing with transformations, right? We were talking about how, let's see here. We're talking about how if it affects just the x or if it affects the whole equation, it's either going to be horizontal or it's either going to be horizontal or vertical, and so we have the same thing here. Okay, this is the parent function. And it's going to be simply 2 to the x power. Y is equal to 2 to the x power. Okay, and here at 0, it's always going to intersect at 1, right? Because 2 to the 0 power would just give you 1. So that's 1. And here, what is this doing? It's affecting just the x, so it's actually going to be a horizontal shift. And it goes to the right 1 unit. Okay, so in this case, and I want you guys to write it down here. I'm going to do it over here, just so that you guys can see. It's actually going to just shift everything over to the right, right? So this is going to look a little bit like this. Sorry, it should still have an asymptote at y is equal to 0, but that's exactly what it should look like. Here, again, it's affecting just the x, so we know it's horizontal, right? But this time we're multiplying, so this is either going to be a stretch or a shrink. Now, for horizontal, it's always the opposite of what you think. So even though this looks like a shrink, it's actually going to be a horizontal stretch. And it's a horizontal stretch by a factor of 2, right? So if my original one looked like this, then my new equation is going to stretch out more horizontally. It's going to go up slower. It's going to look like that. Kind of, sort of. Sorry about this terrible drawing. Okay, this one is the opposite, right? So it's up to the x, but now instead of a horizontal shrink that was affecting just the x, it was up there in the exponent, this is going to be a vertical stretch, meaning that it's going to go up way faster. Okay, so if this is my original, then this is going to be my new equation. It's just going to go up way higher, way faster. Okay, and this is going to be your initial value at 3 instead of at 1. Okay, because of that 3, that's your initial value, that's your A. This is a vertical shift. Up by 1 unit. So we have an equation here that looks a little bit something like this. Then all we're going to do is we're going to move our asymptote, we're going to move our y-intercept, and everything's just going to shift up 1. But it's going to look exactly the same. And then finally, here, we have a reflection. Now, is it a reflection over the x or over the y? Well, again, you ask yourself, is it affecting just the x or the whole equation? This is affecting just the x, so it's actually going to be a reflection over the y-axis. So this is going to look a little bit something like this. We're going to call this exponential decay a little bit later. This is exponential growth in red. This is exponential decay in green. And we'll talk about that later. But it's going to get really, really interesting. Again, this is one of my favorite units, so I hope that you guys enjoy it as much as I do. Okay, so now you're caught up with the other classes. And I want to go ahead and talk about these two worksheets that I gave you guys today. So properties of exponents. This is for practice, meaning it is not for a grade, okay? So you only have to do as much as you feel like you need, all right? The answers to these are on the board, so if you need to check it, go ahead and check it. The way you do these is very simple, right? It's asking you to simplify your answers, and your answer should only contain positive exponents. So if you have negative exponents, you have to go ahead and take the reciprocal, just like we talked about. This is based on that foldable that I gave you guys last class. Okay, so what you would do is something like this is, okay, well, if I'm multiplying, then I know I got to multiply my coefficients. So 2 times 2 right here, 2 times 2 would give me 4. My variable would stay the same, m. And then what do I do with my exponents? I add them. Whenever I'm multiplying two variables with exponents, I just go ahead and add the exponents. This is going to be 4m to the 5th power. And it's going to be simple as that. Something like number 9 is a little bit more difficult. And I want to make sure that you guys understand this because you will be taking a quiz over all of the exponent rules, exponent properties, and these two worksheets next class, which is on Monday, I believe, for you guys. So expect that, please. You follow the same principles. You multiply the exponents, so 4 times 3 gives you 12. And then you go ahead and add each variable's exponents individually. So a to the 3rd power and a to the negative 4 gives me a to the negative 1. And b to the 2nd power and b to the negative 3 gives me b to the negative 1. Now the problem with this is that, again, they asked for only positive exponents. So what you would have to do is you'd have to convert this into 12 times 1 over a times 1 over b, which simplifies to 12 over ab, which is what you should have on your answer key, right? Something like this, ladies and gentlemen. People are having trouble with these two right here. X to the 2nd power raised to the 0. Anything to the 0 is just 1. But here, we have to remember to distribute the 4, okay? So this is 4 to the 4th power times r to the 0 times 4. Well, in this case, you would get 4 to the 4th power times r to the 0. And, you know, I'm going to let you guys figure this one out. But just don't forget to distribute, okay? You guys have plenty of practice for these. These can get a little bit difficult, but I want you guys to try them out. Make sure that you can do them because I'm going to be quizzing you on this. Again, this is not for a grade. This, however, is. So this one, I want everybody to go ahead and write for a grade on here. Due on Monday. Okay? And I know that these are a little bit trickier, but this is getting to the pre-calculus level. If you notice, this says pre-cal on it, and this up here should be review, algebra 1, okay? Okay, now the way you do these is actually pretty simple once you get the hang of it. You have to go ahead and, number 1, make sure that you have the same base, right? Base is the number that you're raising, or the variable, or whatever it is that you're raising to the exponent. So once you have the same base, 6 raised to the 2x is equal to 6 to the 3rd power. You go ahead and just cancel them out. This cancels out this, right? What I have left over is 2x is equal to 3. And then I just solve. Divided by 2, divided by 2. X is equal to 3 over 2. And please go ahead and box your answer so it's easy to see. I've had people turn in this work that is honestly pretty jumbled up, and so it's hard to find the answer. So make sure that you know where your answer is. But yeah, it's simple as that. It can get a little bit more complicated. Let's look at something like number 5, right? So we have 4 to the p minus 3 is equal to 64, okay? But 64 is not the same base as 4. So what you have to do is you have to think about this, okay? You have to think about it and say, all right, 64 and 4 have to have a common base, right? And it could be 2, it could be 4, right? And you're always going to want to go with the bigger one just in case, right? So you start to think about it and you say, okay, well, if 64 is the same thing as saying 4 to the third power, then instead of writing down 64 on this side, I'm just going to write 4 to the third power. And look at that, now they have a common base, so I can count. I can cross those out, I can cancel them, and I get p minus 3 is equal to 3, so plus 3 to both sides, plus 3 to both sides. P is equal to 6. There we go. People are also having a lot of trouble with number 4. Okay, so let me explain it. You cancel out the 3's. You get negative 3v is equal to 2v. Okay? And when you go ahead and just add 3v to both sides, plus 3v, you get 0 is equal to 5v. Well, when you divide by 5, what's 0 divided by 5? That's just 0. So v is equal to 0. Your answer can be 0, so don't freak out if that's one of your answers. Just roll with it, make sure you did everything correctly. Let's see. One that might be a little bit trickier could be something like number... Well, let's look at how you would solve one that's pretty difficult, like number... Let's see. 18, I think sounds good. Okay. So we're doing number 18. Now, here's what I would do. Before I do anything else, I would set up each one of these, and I would try to figure out what my common base is. Okay? So I have 1/3, 9, and 1 over 27. If you really think hard about it, each one of these has a common base of 3, because 1/3 is just 3 to the negative 1, right? A negative makes me take my reciprocal. You guys should know that from my foldable and properties of powers, power rules. 9 is just 3 squared. And 27, well, 27 is 3 to the third power. 3 times 3 is 9, times 3 is 27. And to make it 1 over 27, well, then I just add a negative. So this is what I actually have. Now I can actually come back in and add my exponents that were given before, and then go ahead and multiply them, right? Because when you raise a power to a power, you multiply. So this is going to be 3 to the negative 1 raised to the 3x times 3 to the second power raised to the negative 2x is equal to 3 to the negative 3 raised to the, oops, it seems like I ran out of paper here, minus 3x minus 2. Okay. Now we go ahead and just multiply this out. So we get 3 to the negative 3x times 3 to the negative 4x is equal to 3, and we have to distribute to the 9x, right? Negative and negative make a positive. Minus 2 times minus 3 gives us a positive 6, so plus 6. Now, when we go ahead and multiply two variables, we add the exponents. So negative 3x and negative 4 gives us a negative 7x is equal to a 9x plus 6. We go ahead and let's say we subtract 9x from both sides. Minus 9x, I get, it should be negative 18. Sorry, my math was off. Negative 16x is equal to 6. And if I divide by negative 16, I can simplify this into 3 over 8. And because one of them is negative, it's negative. So negative 3 over 8. I know that was a long process, but you guys have the option of pausing, reviewing, going slower, looking at it again. Make sure that you guys really understand this, okay? I'm going to give you the rest of the period to just work on this stuff. If you are finished with this, go ahead and just work on your project. Start talking to your team about what you want your project to look like, what banks you guys are going to research, because you guys each have to do a different bank account. So make sure that there's no overlap in bank accounts. Let me know if you guys have any questions, guys. I will be back tomorrow, Friday, and I will have tutoring after school on Friday. So if you guys do need any help, I will be available at that point. And if not, then this video is going to be available for you guys over the weekend. So please let me know if you guys have questions, and go ahead and get to work.